Okay, so right now, two absolutely incredible cosmic dramas are playing out at the same time. On one hand, you've got our own sun, and it's waking up in a huge way. And on the other, a mysterious visitor, something from way outside our solar system. But here's the real kicker. What if these two totally separate events are actually connected?
And look, this isn't just some cool, far-off space story. This is happening right now, and it matters to us, because what's brewing out there isn't staying out there. We are talking about one of the most intense bursts of solar activity we've seen in decades, and it is literally turning to face us as we speak.
All right, so let's start with our own star, the sun. Because honestly, that's the most immediate piece of this puzzle. We are watching the buildup of what could be a truly massive solar storm.
So first, you got to know what we're up against. It's something called a coronal mass ejection, or a CME. Now, the easiest way to picture it, think of a colossal cannonball, but instead of iron, it's made of superheated plasma and magnetic fields just blasted out from the sun. And right now, the sun is firing off some of the biggest ones we have ever seen. No joke.
Okay, now here's the crucial part. So far, all of this insane activity has been happening on the far side of the sun. You know, the side facing away from us. We're talking massive X-class flares, that's the most powerful kind there is, and these huge CMEs. But the sun rotates, and in just a few days, that entire incredibly volatile region, just packed with these dark, unstable sunspots, it's going to be staring right at us. The storm is coming our way.
All right, now let's switch gears and bring in the second player in this whole cosmic drama. It's an object called 3I/Atlas. And listen, this is not just any old comet. This is an interstellar visitor, a traveler, from a whole other star system, and it just made its closest flyby of our sun.
And to give you an idea of the trial by fire it just went through, I mean, look at this. Out in deep space, the radiation it was dealing with was, well, practically zero. But as it swung past our sun, it got blasted with an absolutely unimaginable amount of energy. And get this, it happened right when the sun was in the middle of this historic, angry outburst.
So being in that intense environment caused some really strange behavior. You see, based on all their models, scientists expected the comet to hit a certain level of brightness. But what they actually saw? Whoa. It was dramatically, unexpectedly brighter. It's just not acting like any comet from our own solar system would. Something's different.
So, let's just recap the mystery here for a second. Its path, totally normal. It's exactly where we thought it would be. But its behavior, anything but. It's brightening up way more than it should. And when we look closer, its composition is weird. It's a real puzzle. And here's a key fact. We know for sure it was directly in the line of fire of those huge CMEs we were just talking about.
So you've got these two major things happening at once, a superactive sun and this bizarre interstellar visitor. The big question is, could this be more than just a crazy coincidence?
And this is where we get to the core idea from the source material, and it's a wild one. What if this visitor didn't just get hit by the storm? What if it actually helped trigger it? Okay, so the theory goes a little something like this. Step 1, a big object, like our visitor 3I/Atlas, lines up perfectly with the Earth and the Sun. Step 2, this lineup kind of messes with the whole solar system's delicate electromagnetic balance. And step 3, if you've already got some angry, volatile sunspots on the Sun, this little disturbance can be the final push that makes them blow. And here's the absolute kicker. On October 21st, the biggest CME of this entire cycle erupted at the exact moment that the Earth, the Sun, and 3I/Atlas were all in a perfect line.
Now, I know this might sound a little out there, but there's actually a fascinating historical precedent that gives this idea some real weight. We just have to look back to 2003.
So let's walk through the timeline of the infamous Halloween storms of 2003. This was one of the most intense solar events we have ever recorded. Check this out. Major activity kicks off around October 26th. Then, just 2 days later, on the 28th, right as things are really heating up, the planet Mercury creates a perfect alignment with the Earth and the Sun. And what happened next? A solid week of extreme, Earth-directed solar fury.
And believe it or not, this isn't just a one-off thing. As geophysicist Stefan Burns points out, they've actually noticed that when Mercury lines up like that, we usually get a spike in solar activity. This suggests there's a real pattern here. These alignments can, and apparently do, mess with the sun's behavior.
Okay, so what is all this cosmic drama? The big storm,
the strange visitor, these weird alignments, what does it actually mean for us, down here on Earth?
Well, when one of those CMEs slams into our planet's magnetic field, it triggers what's called a geomagnetic storm. We measure them on a scale from G1, which is pretty minor, all the way up to G5, which is classified as extreme. Right now, we're already sitting in a G1 storm, but the active region that's swinging around to face us, that has the potential to unleash a G5.
And let's be really clear about this. A G5 storm is not just about getting to see some pretty auroras further south. For our modern tech-heavy world, the consequences could be severe. We are talking about things like widespread power grid failures, blackouts, damaged satellites, which affects everything from GPS to banking, widespread communication outages. It's serious stuff. And that's why the source material really emphasizes that having some basics ready, water, food, a battery-powered radio, is just plain smart.
So all of this leaves us with a pretty powerful final thought. We spend so much time and energy staring right at the sun, trying to predict its next big eruption. But maybe we should also be paying attention to the cosmic ballet of planets and visitors swinging by. It's a wild idea to think about, right? That the key to the sun's next move might not be on its surface at all, but hidden in the subtle alignments of the entire solar system.
Welcome to the debate. We are watching space weather unfold in a really spectacular and possibly connected duality right now. On one side, we've got this extreme solar activity. Easily one of the biggest flare periods in decades, with relentless X-class flares erupting from these massive multiplying sunspots, which are currently rotating around the far side of the sun. And then, simultaneously, we have this interstellar object, 3A Atlas. It just made its closest pass to the sun. It's perihelion, out at about 1.36 AU, and it has brightened, well, dramatically, far beyond what any of the models predicted. So, the core question, really, that just jumps out of this synchronized timing is, well, did the superior conjunction, that's the alignment of 3I Atlas, the Sun, and Earth, which happened back on October 21st, did that actually confirm a theory about non-gravitational electromagnetic influences?
Did the presence of this large plasma object somehow provoke or amplify the extreme solar activity we saw? I'll be arguing that yes, this temporal alignment and the surge in flares, they validate that electromagnetic influence hypothesis.
Okay, I come at it from a different angle. While the sheer timing of these two impressive events is certainly striking, I think, I maintain that making a direct connection between them is, well, it's a pretty monumental leap. From my perspective, these phenomena are robustly and frankly adequately explained by separate, well-established physical mechanisms. The sun's activity is simply the extreme end of its own internal cycle, the natural evolution of these giant sunspot groups. And 3I8L's sudden brightening, that seems a direct, measurable consequence of just immense heat and kinetic energy exposure near the sun.
Honestly, I think dismissing this synchronicity as mere coincidence requires ignoring some of the strongest temporal data we have. My position is that the presence of 3I Atlas, which is, a sizable body of plasma, rock, and gas, in conjunction with Earth, acted as a kind of momentary influence on the inner solar system's electromagnetic dynamics. And this isn't just a gentle wave. The alignment seems to act almost like a cosmic short circuit, intensely focusing the existing magnetic energies within the sunspots and, well, forcing the eruption. The supporting evidence here is really twofold. First, the hypothesis actually allowed for a successful forecast of enhanced activity. The biggest coronal mass ejection, the CME, it occurred precisely around the time of that superior conjunction on October 21st. Second, it's not a unique event.
We know, historically, the 2003 Halloween storms, which were famous for their intensity, they were also temporally aligned with a superior conjunction of Mercury. Now, Mercury and Earth are the only two planets with strong magnetic fields, and their alignment seems to consistently influence the solar circuit. And then you have this interstellar object brightening exponentially more than expected. That indicates a systemic, rather than just a superficial, influence at play here.
Okay, I hear the argument for a pattern, but making a transient interstellar object the cause or even the primary trigger of decade-level solar activity just because it happened to be passing by, well, that feels like an extraordinary claim. And extraordinary claims, as they say, require extraordinary proof. The evidence linking 3 Atlas as a causal factor is, as far as I can see, purely circumstantial correlation. Let's look at the established mechanisms, starting with the interstellar object itself. At 1.36 AU, it was absolutely blasted by solar energy. We're talking something like 735 watts per square meter. And critically, it was hit by a whole bunch of huge CMEs originating from those far-side sunspots, right? This kinetic impact and intense heat provide a clear physical mechanism. When a comet-like object gets exposed to that much energy, it releases massive amounts of dust, gas, and plasma. The brightening, including maybe some observed aurora-like effects from plasma currents. Well, that's simply what happens when an object gets violently hit near perihelion. No special circuit dynamics needed, I think. And regarding the sun, you yourself called the activity one of the biggest in decades. That level of severity is a natural manifestation of the sun's internal dynamo. These sunspots are getting bigger, they're multiplying, and they are inherently big X-class flare players. To attribute this scale of activity to an object that's merely passing through, well, it seems to overlook the sunspot's inherent magnetic complexity and stored energy. It minimizes the fundamental power of the solar cycle dynamics themselves.
I see why you'd emphasize the overwhelming energy input, but that's precisely where I think the established mechanisms fall short. We really need to talk about the magnitude of 3I Atlas's anomalous behavior, because the difference we observed is far more than simple off-gassing models expected.
Okay, I'll concede the brightness was unusual, yes. But let's consider the cumulative energy input. The object was exposed to intense heat near the sun, and it got that kinetic impact from multiple CMEs. We know this impact caused it to release dust, gas, plasma. So why can't we just argue that this rapid, forceful injection of energy, the CMEs literally slamming into the object, adequately explains the high magnitude of off-gassing? The release is likely amplified by those impacts, creating intense electrical currents around the object, maybe similar to what we see with auroras on magnetized planets like Jupiter. Simple energy input, perhaps dramatically amplified by the solar storm? That seems to suffice, doesn't it?
I'm not convinced that simple energy input suffices when we look closely at the numbers. The anticipated apparent magnitude for 3I Atlas at perihelion, it was expected to be around 9, maybe a bit brighter. The actual observed magnitude was around 7.5. Now, for anyone not familiar with this scale, that is not a linear difference. Magnitude is a logarithmic and inverse scale. This difference means the object wasn't just marginally brighter, it was exponentially brighter than simple heating models would account for. That degree of, let's call it, unique dynamics, it demands an explanation that goes beyond basic vaporization or just getting hit. It suggests a systemic influence, an interaction with the solar circuit that changed the object's energetic state fundamentally, just as the solar dynamics were changing fundamentally.
That's a strong quantitative challenge, I admit. But let's talk timing again, because that's really the heart of your argument, right? You rely heavily on this historical precedent. You claim the credibility of the electromagnetic hypothesis lies in that 2003 Mercury alignment.
Precisely. The historical data provides compelling justification, I think. The 2003 Halloween storms were immensely intense, and they coincided exactly with the Mercury-Sun-Earth alignment. This strongly suggests that the arrangement of large magnetic entities, in that case Mercury and Earth, influences the solar system's energetic circuit. So what happened on October 21st? We had 3IATLS, a highly charged large plasma and rock entity near the Sun, seemingly substituting for Mercury's role in the alignment with Earth. And it coincided perfectly with the biggest CME launch of this period. This suggests that alignment is a substantial modulating factor, not just some random coincidence.
That is a compelling correlation, I grant you. But let me introduce the concept of necessary conditions here. You acknowledge that the sunspots are the engine, the source material. Even around the 2003 storms makes the critical point that, quote, you need the sunspots to do it in the first place. Extreme solar activity, the kind that involves potential X-class flares, double-digit even, relies fundamentally on the stored, complex, and highly stressed magnetic fields within the sunspots themselves. An alignment might act as a subtle trigger, maybe the final nudge, sure. But the primary cause has to be the big flare players that were already growing and multiplying on the sun. A temporary external object doesn't create a sunspot group that's described as one of the biggest in decades.
Oh, I agree completely that the sunspots must provide the stored energy and the requisite conditions for the outburst. Absolutely. But if alignment influences are critical factors in predicting the timing and maybe even the scale of these massive energetic movements, if we can accurately forecast the when of the largest CMEs based on these conjunctions, then the influence is substantive, isn't it? The hypothesis argues that the object's alignment with Earth provided the necessary momentary focusing mechanism to rapidly destabilize an already ripe magnetic region. It's about the timing of the release.
I would argue, though, that your focus on the trigger mechanism potentially shifts attention away from the primary risk drivers. Let's just shift our focus for a second to the immediate consequence and the context of risk that faces us literally right now. The imminent threats of severe geomagnetic storming predicted for early November. That's entirely driven by those massive sunspots rotating into our view. That's the immediate danger.
Right. And while acknowledging the immediate, severe Earth-facing risk, and absolutely, nobody would dispute the dangerous power of those rotating sunspots, I see why you think that's the only relevant focus. But let me offer a slightly different perspective. Understanding the trigger mechanism is scientifically vital for our global predictive capacity. If the alignment dictates the timing of the largest eruptions, that's not just some scientific curiosity, it's a critical piece of the puzzle for space weather forecasting. The very fact that the dramatic solar activity began precisely during the conjunction of 3 Atlas with Earth suggests that systemic influences are necessary inputs for modulating these huge energetic movements.
I understand you're framing the inner solar system as this massive electrical circuit, but I still question if a transient object like 3I Atlas, does it really have the mass or the persistent field to meaningfully influence the sun's core dynamics in the same way that a stable, magnetized planet like Mercury apparently does? You seem to be equating the influence of a short-lived plasma object with that of a constantly orbiting massive planetary body.
I guess I'd frame it differently. The principle remains. The inner solar system's highly energetic environment seems influenced by the proximity and alignment of large entities, whether they are permanently magnetic planets or transient, highly charged plasma objects near the sun. The fact that this specific interstellar object brightens so anomalously at the same time the biggest CME launched, that strengthens the case for a unified electromagnetic dynamic at play.
And, well, I suppose that is the core difference between our views right now. You see a unified systemic dynamic confirmed by temporal correlation, and I see 2 simultaneous, very impressive events, both of which seem to fit quite well within the existing framework of extreme solar cycle behavior and intense solar radiation exposure.
So to summarize my position then, the dramatic temporal correlations, the unexpected exponential brightening of 3 Atlas, and the initiation of extreme solar activity immediately following its superior conjunction with Earth, they lend significant weight, I believe, to the hypothesis that system alignments involving large plasma or magnetic entities are necessary factors that influence solar dynamics, and crucially, they might allow us to successfully forecast the timing of major events.
And I conclude that while these simultaneous events are undeniably striking, established physics provides a sufficient explanation for both. The extreme heat and the direct impact from multiple CMEs account for 3 Atlas's anomalous brightness, and the inherent power and complexity of these massive multiplying sunspot groups account for the extreme solar flares. The hypothetical electromagnetic influence, while fascinating, it needs more definitive proof than correlation, I think, to be accepted as the primary driver of such massive solar outbursts.
Right. Regardless of our differing views on the precise mechanism, though, I think we are in full agreement that this is an extraordinary period in the current energetic environment.
Absolutely. Continued observation is vital. We are watching, well, potentially history unfold here, especially as those major sunspots rotate Earth-facing
and also as the ESA's JUICE probe begins taking observations near 3A Atlas starting, I believe, November 2nd. There is certainly more to uncover.
Thank you for joining us for the debate.
And we encourage our listeners to continue exploring the complex dynamics of solar weather, planetary resonances, and the truly unique behavior of these interstellar objects. It's a fascinating time.